Okay, hello. I'm just doing a couple of tests here to see if I can get everything correctly set up in OBS. I've been trying to fiddle around with the YouTube settings and how to get the broadcast permissions and stuff like that, and those things should be in order. But I'm curious if you guys can hear me well and if there's any audio coming out to the channel. So yeah. If there's someone watching this, then please let me know in the chat. Yeah, it sounds like the audio is working, and I'm going to see if we can share the screen as well. So there, the game should now be visible. Are you able to see the main menu of re-entry right now? Please let me know in the chat as well. And of course, I appreciate everyone who is helping me out here on this short little test. So once I get all these things up and running, okay, thank you, Alex. So one of the things that I want to do going forward is to do short streams showing some new features, showing stuff that I'm working on, trying to kind of be open and a bit transparent with some of the upcoming features that I want to talk about. So today, for the next 15 minutes, I just want to quickly run through a couple of tests to see how broadcasting works on YouTube. And then secondly, I'm also going to showcase some of the things that I've been working on when it comes to Gemini in the upcoming 0.93 update. So if I now dive into reentry, one of the things that you will get in 0.93, which I'm currently working on right now, is some major updates to the onboard computer inside of Gemini. So I can jump into, for example, the free play in Orbit, just to get into the Gemini cockpit, and then I'll quickly show you what I'm talking about. And please let me know in the chat if my audio is still working well and if there's any glitches in this on the stream, if there's any strange stuff going on, then I would like to know about it so I can correct it and make the stream as good as possible from a technical perspective. I've also tried to balance the audio from the game with my voice, so I hope that there won't be much sound effects kind of overriding what I'm saying. Okay, so I've now loaded up into the Gemini craft. I'm now in orbit of about 120.5 nautical miles of apogee and a perigee of 84.2 nautical miles. And I'm going to now quickly show you some of the updates on the OBC. And I'll tab a little bit back and forth with the chat. If I'm doing a real stream, I'll set up a secondary computer that will monitor the chat and everything like that. But for now, I'll just use Alt Tab just in case. Okay, so one of the bigger improvements that 0.93 will give you is an update to the onboard computer, as I mentioned. And the onboard computer basically consists of an MDU, which is basically the display of the computer, and it's located over here. It got an address and a message. The address is kind of what memory block you're looking at, and the message is the content of that memory block. And using these buttons here, you can read out, basically take a peek at the memory. It will then show me what data locates at this memory address, and then you can enter another value if you want to override that. First of all, I'm just going to get some more lights on, just to get everything nice and bright. Secondly, the control panel for the computer itself is located in the middle. All of the changes that I've been performing on the OBC is in the Catch Up module, which is the module that you will be using the most in Gemini. So Catch Up is everything about performing burns in orbit, maneuvering basically. So the Catch Up module basically, and I'm going to set this to Catch Up, and you can see that the green light on the aux tape indicator is now illuminated, which means that the tape is now loading into memory, and that usually takes about 10 minutes. So I'm going to use timescale to do that. But as I was talking about, the catch-up program is all about performing burns, and this is where you do all of the circulation burns and rendezvous burns in orbit. So I made some tools to make all of that much simpler. If you haven't been using Gemini before, then that's fine. This is probably a good introduction to new features. And if you have, you will probably be happy to learn that you no longer need to care about the kilometers versus nautical miles unit in the OBC in the same way as before. You don't need to set a target orbit and calculate all these things yourself. The real Gemini OBC actually knew about a timestamp, and that's the time of ignition, and then a delta V vector at that timestamp. And that's basically all it had to know about. The third related view of the computer is the IVIs, and this is basically an indicator that can show you in what direction you need to perform a delta V burn to reach the target. And this is basically a very simple indication of showing you in what direction the RCS thrusters need to be fired. Because the Gemini used the translational thrusters for doing all of the delta V burns, which basically is the RCS or OMS, it allowed the spacecraft to perform burns in any direction at any attitude. So it doesn't really matter what attitude this spacecraft is in. I could basically perform any burn in this attitude I'm currently in. All I need to do is to fire the correct thrusters in the based on what this IVI is telling me. So this is where everything gets quite interesting. So now I'm going to request a burn. So I've created some new tools to simplify all of that. You have something called mission tools, and this is where I plan to add almost everything related to burns. So here you can find some data forms. I'm going to perform a catch-up maneuver burn, which is basically just a catch-up module. It could be a circular orbit, it could be rendezvousing, everything goes into the same pad. And then I'm going to request a burn. And if I now quickly take a look at my current orbit, you can see that I am in an elliptical orbit, and I want to circulate this at, let's say, perigee 84.2. That will require me to perform a retrograde burn, basically, to reduce apogee down to 84.2 at the perigee passing. So I'm going to go into the mission tools, and I'm going to request circulate at perigee. And the first thing that you see is that I've now received a DCS uplink message. This is a summary of the burn from ground, but also all the data related to this burn has now been uplinked from ground into the computer. Doing all of this is not required. You can plot all of this data in yourself if you want. So The OBC in catch-up mode basically works as a calculator. And right now, I've received all the parameters I need to insert into the computer to perform a calculation. So I'm going to type down the most important bits of data here using this catch-up maneuver pad. And the first thing is that I'm going to perform a PE circulation burn. So then I'll just do PE circ. And I'm going to use the RCS for that. I don't have too much choices. And then I want it to be an OBC control burn, which means that I'll use the OBC to perform the burn using that guidance. The next data is GETI. This is basically the time of ignition, and it consists of two fields. Hour in ground elapsed time. That's basically my mission timer. Minutes, and then seconds. So the pad here now shows me that the data here at JT, the first row, is 00111. So if I'll just quickly plot this in, it will if I plot this in now, it will then suddenly start to make sense. This now indicates that 00111 is basically 1 hour into the mission and 11 minutes into the mission. And then I'll look at the next one. It's always a 0 in front. So 24:56. 24:56 indicates that my burn is not my burn time, basically the time of ignition, is 1 hour 11 minutes 24.56 seconds into the mission. So this is basically the timestamp of the burn. The next three values is the burn vector, and this is a local burn vector. So at this time, the spacecraft will have a local vertical, and I want to perform the burn in a prograde or retrograde direction. In this case, it's going to be retrograde because I'm bringing apogee down. So if I take a look at this number here, and you see that the value is 90657, and I'm also going to plot this into this field here. So 10657. And what this means is that if you take a look at the OBC, the keyboard here doesn't have any plus or negative buttons for the sign, so I can't input a negative value. So the computer on board Gemini actually uses 9 as an indicator of a negative value. So if the first digit here is a 9, it means that my burn is going to be a negative direction. If it would be a 0, then it would be a plus. So basically this reads plus 65, and then you notice that in the pad the last digit is a decimal. So that burn is going to be something like this, and then of course this was negative. So I'm going to perform a burn of minus 65.7 feet per second in the negative direction, basically retrograde at this timestamp. All the other ones are basically 0. The burn time is set to 32 seconds. Attitude doesn't really matter. I can perform the burn at any time. And then you have an 84.2 nautical miles of a circular orbit if I perform this burn correctly. So with that said, I'll hit Roger. I now have all of the pad data in here. I'll make this a little bit smaller. Now I will need to wait for my computer to load, so I'm just going to use timescale. There, it's done. Now I will need to verify that all of this data is correct. So if you take a look at the pad, you can see that there's a couple of numbers on the right side here. So the first memory address I want to check is 01. 01 should contain the first row of digits here, so 00111. And you can see 00111 at address 01. So that's the time of ignition in hours and minutes. If I now clear and check the next memory address, that's 02, you see 24.56 seconds. And then 25, it's the local delta V in the x-axis of the spacecraft at the time of ignition. That should be minus 65.7, and 26 should be 0, 27 should also be 0. And that's it for the burn. All of these data points that you can see on the top here, and where I'm drawing, is basically things that should be in the OBC. While this is just info. So you don't need to care too much about it, but burn time is good to know, and the predicted orbit is also good to know. Attitude will be the direction of the burn vector relative to your F-dice. So you can basically, if you center it or if you follow the needles, it will take you through the right of the eye of the burn. But we don't need to care too much about that. All we know now is that all the data that we got in the pad is also correctly inserted into the computer by use of DCS. So I'll just reset the DCS light, and I can go ahead and hit start. And every time you change any of these values, it means that you change the burn that you want to plan. You need to hit reset and start again to recalculate the burn. So the next thing I want to do is to just turn on my OMS to start maneuvering towards the sharp end forward, which is basically a prograde direction. And as I rotate, you will see that the IVIs now behave in a very different way than you might be used to from before. It basically tells me that given your current attitude, this is the direction you need to burn in order to reach the goal, but only if you don't do that at the correct timestamp. And we're currently not there yet. So there's another core in the memory called 83, and that's core. And this is the time to go. This is basically the time to ignition. And if I now clear this and I hit readout, I can keep spamming this. And if I time scale, you can see that it has a special format. So the first 3 digits is minutes until ignition, and the last 2 digits is seconds. So it's like minutes, 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 and seconds. That's basically how you read these values here. So I'm going to hit clear, and I'll still do some spamming. And if I would follow the correct procedures for a burn, I would, at about 10 minutes before ignition, at this time, I would set the event timer to 10 minutes and then start to make it count down. But I'm not going to do that right now. I just want to, keep this test short. So I'll time scale a little bit more. And now we're basically about 2.5 minutes away from the burn. And I'll take a look at the direction. I'll go into rate command slightly. I want to kind of tune so that most of the burn vector is in one direction only. And if I can zero all of these out with the exception of this forward and aft, it basically means that all I need to do is to burn aft to reach the target. If I would be the wrong way, you see that I would need to burn aft, but also a little bit right to reach the vector. So it makes burning a little bit harder. But if you can center everything perfectly, then you should be fine in one direction only. There will be some residuals that you can fix. So now I'll time scale a little bit more. About 20 seconds. Go all the way down to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and ignition. Oh, and then in the aft direction, you can see that if you do it the wrong way, you will see that it starts to count. And since I'm now facing forward into the flight path, I need to burn the aft vectors. As you can see, I'm now kind of braking and bringing perigee down. So if you look at the orbit view of the map, and then you can see that AP is now coming down. I do have some residuals, which I can also quickly clean out if I want. But the most important thing is to get the major part of the vector done as fast as possible. But if I wanted, I could have done this burn in another attitude as well. In that case, burning could be a little bit slower in a couple of directions based on what jets are, what jets you're using. Like if you would be looking straight up, you would only have one jet that could perform the burn instead of two. So if I now look at the external view, you can see that I have two jets now. But if I would be sideways, I only have one jet available. Once the burn is complete, I'll hit reset on the computer, or else the IVIs will go crazy eventually. And if I take a look at the map view again, you can see that I'm now in a pretty circular orbit, which was the orbit I planned to reach. And if I would perform the same burn using a rendezvous, for example, if I hit request rendezvous now, you can see that I now received a new burn. And the computer has now been uplinked with new DCS data, which means that the new burn parameters should be in, let me clear that, 01, should be in. So 6 hours into mission, 14 minutes and 41 seconds, and we will have a delta V of positive 136.8 feet per second to reach Agena. And all that, you need to do now is to hit start, 83, wait for the burn to count down to 0, and perform the burn in by zeroing out the IVIs. That's basically how the new OBC computer will work. There is a checklist for circularizing the orbit. It has been updated to reflect these new changes. Same accounts for rendezvous, which basically consists of two burns. One is the rendezvous burn, and then the second burn is a simple circularization at apogee or perigee if the rendezvous was lower, to kind of close the home end transfer. And then there's a couple of other setup, for example, using the encoder and the radar and stuff like that. And lastly, I've created a new Academy lesson. So if I go into the Academy and Gemini, I've created a new lesson that allows you to go through all of these procedures in detail with Patrick as the instructor. So yeah, that's one of the features that I'm working on right now for 0.93. I'll continue to work on that for the rest of the day, and hopefully I will be able to post this on the alpha floor maybe in the evening or even tomorrow. We'll see how fast development goes. So with that, I want to thank you all for helping me run through this first test, so I can learn kind of how it works to be streaming on YouTube. So yeah, thanks again.